Okay, number 4. So this one, we're going to divide by 9. And there is a negative in the problem, but the negative is not attached to the number that's on the variable. So we're not going to flip the sign here. The only reason we would flip the sign is if this 9 was negative. So don't look at this one. Look at the one attached to the variable. If it's that one's negative, then flip it. If it's this one, it does not change anything. So it stays the same. Draw your number line. So -2, one bigger, one smaller. It'll be an open circle because it is not equal to, and then x is greater than -2, so it goes towards the -1. Okay, go ahead and try 7 and 8 on your own. So pause here, practice those two, and then check to see if you got them right. Okay, you should have divided by 4. So again, because the number that's attached to the variable is not negative, we're not flipping this. Doesn't matter that that one's negative. So -9 and then x. And then your graph should have -9 in the middle, one bigger, one smaller. So then a circle on the -9, and because x is greater, it goes towards the -8. Number 8, because the number attached to the variable is negative this time, so attached means it's stuck to it like -6x, or it's within the same fraction. So because the one attached to the variable is negative, we're going to flip after we multiply this, or before. So flip the sign, and then when you multiply you get -24, and then graph. So you've got -24 in the middle, one bigger, one smaller. So it has a circle and is less than. So the last thing we're doing today is word problems. So the first couple just gives us a picture, and you need to write an inequality based on that. So this first one tells us that the maximum speed on this highway is 65. So basically we're writing an inequality that shows the speeds that are acceptable based on this sign. So the speed should be 65. So now you have to decide, is it less than that, or can it be greater than that? Can it be greater than or equal to 65, or less than or equal? So your speed should be less than the maximum speed, or exactly the maximum speed. So it should be less than or equal to. So go ahead and try this one on your own. So this one is help wanted for this store. They pay $6.15 per hour and up. So the pay should be greater than or equal to $6.15. So now on these last few, you are writing an inequality and also solving it. So these are very similar to the word problems that we've done with equations. The only difference is figuring out that symbol. It does not say that we have to graph it, so we're just going to write and solve. So your brother has $2,000 saved for a vacation. His airplane ticket is $637. How much can he spend on everything else? So we're looking for the rest of his vacation money. How much can he spend? So his total is $2,000. Now because he has $2,000 and he can't spend more than what he has, what he's spending should be less than or exactly $2,000. So he's already spent $637. We want to know how much more he can spend. So plus how much more would be less than or exactly $2,000. So to solve it, you're just subtracting $637. So x should be less than or equal to $1,363. So he can spend exactly $1,363 or anything less than that and still be within what he had. Number 2, Janet needs to travel 275 miles for a conference. She needs to be at the conference in no more than 5.5 hours. What is the slowest average speed that she can drive and still arrive on time? So this one you kind of need to know some background information. You may have talked about this in science, I'm not sure. But there's a formula that's distance equals rate times time that would be helpful here. So the distance that she needs to travel is 275 miles. And she needs to be at the conference in no more than 5.5 hours, 5.5 hours. So that's the time. We don't know the rate, which is the speed. So now we need to figure out the symbol. So if she wants to be at the conference in no more than 5.5 hours, what's the slowest speed she can drive and still arrive on time? So we want her rate to be greater than or exactly some speed to get there on time. If she wants to be there on time, she has to go a certain speed or faster. That's why it's greater than. So if you divide 275 by 5.5, let me get a calculator. So 275 divided by 5.5 is 50. So 50 is her rate, or anything more than that would get her there on time. Oh, label would be miles per hour. Okay, one more together. So the student council votes to buy food for a local food bank. A case of 12 jars of spaghetti sauce costs $13.75. What's the greatest number of cases of sauce the student council can buy if they can use at most $216 for the project? So again, just like equations, look for a total. So here's their budget, $216. They can't spend more than that. It said use at most, so they can spend less than that or exactly $216. So they have cases that they're buying for $13.75. So here's where you might get a little bit confused if you're not careful. So what's the greatest number of cases? It's asking how many cases we can buy. The fact that there are 12 jars inside of that case does not matter at all. So that's extra information that's not needed. It's just asking how many of these whole cases for $3.75 can they buy. So it's $13.75, sorry, times however many they're buying, which we don't know, so that's X, should be less than or equal to 216. So to solve that, divide by 1375. So 216 divided by 1375 comes out to be 15.7, then a bunch of decimals, rounded off like that. But we want an actual number of cases that they can buy. So this says X has to be less than 1571. So even though this would typically round up, like when you're used to rounding in math classes usually, you round up if it's above 5. But since this says less than, we can't buy any more than that. So it has to be X is less than or equal to, because they could buy exactly that, 15, the label was cases. Okay, try this one on your own really quick, and then we'll go over it. So you need to buy stamps to mail some letters. Stamps are 34 cents each. What's the maximum number of stamps you can buy with $3.84? So the total here is $3.84. The stamps are 34 cents each, so that has the X on it. And if you have $3.84, you can't spend more than what you have. So the number of stamps you buy needs to cost less than $3.84 or exactly $3.84. So then to solve that, divide by 34 cents. So $3.84 divided by 34 cents is 11.29, bunch of decimals. So again, just like that last one, you can't buy part of a stamp here, so you have to buy less than that. So it's going to go down to 11 stamps. So make sure if you get a decimal, sometimes decimals are okay. If the answer is money, it's okay to have a decimal. But if it's number of stamps or number of cases like the one was before, you need to round it off to whatever makes sense. So with the remaining class time, you need to work on the homework that your sub passes out. You may listen to music with one earbud, but please make sure you are working because we are going to move on tomorrow, and you need to know how to do this to do tomorrow's lesson. I'll see you then.